Okay, today we're going to continue with inequalities. So we're going to turn to our table of contents to page 31. And on page 31, you are going to write one-step inequalities. One-step inequalities. Okay. Once you have that titled, you're going to turn to page 31 in your notebook. And we're going to title it again, One-Step Inequalities. And then don't forget to number your page, and it's page 31. Okay. Once you have that, your teacher should have given you a foldable, and you'll need the foldable from your teacher, and then you'll need like 5 different colored pencils. I have purple, orange, red, green, pink, and light blue, but whatever 5 you choose to use. The foldable is going to come to you looking like this. And just like yesterday, you're going to turn to the page that has the examples on it and the number lines and fold in the tabs along the dotted line so you have 4 like windows, kind of like that. Okay? And even though we have 4 of these set up, this video is only solving one-step equations with addition and subtraction. So we will only be filling in the top 2 today. We'll do the other 2 later. So let's start with our flaps closed like this. The first one we're going to talk about is one-step addition inequalities. So I'm going to take my pink colored pencil, and I'm just going to put a addition sign up here to label the addition one. Okay. And then before we start on the examples, we're going to go over here where it says one-step subtraction inequalities. So you've guessed it, we're going to put a subtraction sign right there. Okay. And I used light blue. Okay. Then what we're going to do is we're going to open our flap for one-step addition inequalities. Do not glue this in yet because you're going to be moving it around to work with it. So we're going to go here where it says example number 1, and all we have on here is the number line. So we know at the end we're going to be graphing our answer on the number line. Your first example that you're going to use, and I am going to use my dark blue for this, is x plus 3. So we're going to write x plus 3 is greater than 10. Now, yesterday, when Miss Lang was doing the video, she talked about an inequality being similar to an equation. And this should look very similar to an equation that you've seen in the past. Before, you would have x plus 3, but instead of the inequality sign, we used to have an equal sign right there. Okay? Today, we're putting in an inequality sign. So the process to solve it, though, is exactly the same thing that you would do if it was an equal sign. So you're going to draw a line at the inequality sign, and then you're going to put your pencil on your variable. Here is your variable. It says to add 3. So just like when it was an equation, we're going to do the exact opposite, or the inverse. So we are going to subtract 3, subtract 3. Now, if we finish our problem, the 3's are going to cancel out. And what we have on this side of our inequality is the x. Now, in the past, we would write an equal sign, but since there is no equal sign, what we do is we just carry down our inequality sign. So we're going to carry down the greater than sign, and now we're going to do the math of 10 minus 3, so it is 7. And then we box our answer. So what we have here is that x is anything greater than 7. And what that means is when you substitute in a number, you can put in any number that is greater than 7 right here, and it will make this a true statement. So if I put in a 10, 10 plus 3 is 13. That's greater than 10, so that makes a true statement. Any number that is bigger than 7 will make this a true inequality. We're going to show all of the possible choices for our answer on our number line. So just like yesterday, when you're graphing this, you need to put the 7, put a couple numbers above, so 8 and 9, and a couple numbers below, 6 and 5. Since this is just the greater than sign, we learned yesterday that you have an open circle or an open dot. And we said x is greater than 7, so we want to show our arrow on all the numbers that are greater than 7. So that means 8, 9, 10, 11, 12. It's going to just keep going, so I put my arrow on there to show that it's going to keep going in that direction. Okay. Another way to look at this is if you think back to elementary school, you put your pencil on your variable and you say, is the alligator eating the variable or not? Because the alligator eats the bigger number. So since it's eating the x has to be bigger, so we would definitely put our arrow to the right. Okay, now we're going to go on to our second example. And this one we're writing backwards. We're actually putting the variable on the right side of the equation because our variable doesn't always show up on the left side of our equation. So this one is 12 less than equal to negative 5 plus a. Okay, we are going to solve this just like the last one. We're going to treat it like an equation, and if it was an equation, we would have drawn a line right here at the equal sign. Okay, and then we put our pencil on our variable, and this says a plus a negative 5. And we were taught to always look at the sign that's in front of the number. So instead of the minus 5, we would write plus 5 plus 5. Okay. The negative 5 and the positive 5 will cancel out, and we'll be left with a over here on the right side of our equation. We carry down our inequality sign, so we carry that down. And then we have 12 plus 5, which is 17. So now this is our answer. There's a couple of ways you can read this. 17 is less than or equal to a. Or if you read it backwards from the a is actually greater than or equal to 17. So we are going to graph this. We know that we need to write 17 and a couple numbers above 17 and a couple numbers below 17. Since this symbol has the or equal to line under there, we know that we must fill in our dot. It can equal 17, or it can be anything bigger than 17. And the way I know that my arrow is going to go to the bigger sign is because I say to myself, is the alligator eating the A? It is, so that means A has to be the bigger item. So I know that anything bigger than 17 will make this a true inequality. So I could plug in 18 for A, 19 for A. I could plug in 100 for A. Anything bigger or equal to 17 will make this a true inequality. All right, that was adding inequalities. Now we're going to go to subtracting inequalities. So our example number 3 is going to be n minus 8 is greater than or equal to negative 11. Okay, the process is the same as with the adding. You're going to draw your line at the inequality sign, put your pencil on your variable. It says to subtract 8, so you do the inverse and you will add 8 to both sides. Now, over here, the minus 8, add 8 cancels out, so you have n left over here. You carry down your inequality sign, so it's going to be greater than or equal to. And now you need to be careful with your integers here. You have negative 11 and positive 8, so you would subtract those and you would end up with negative 3. Now we're going to graph it, and we know we need negative 3 on our number line. And anything greater than negative 3 would go this way. So negative 2, negative 1, and then anything smaller, like negative 4 and negative 5, would go this way. Since this says that it is greater than or equal to, I know at the negative 3 I need to fill in my dot, or my circle. Now I need to decide, can my answer be greater than negative 3 or can it be less than negative 3? So I say, okay, n is greater than or equal to negative 3. So I know my arrow has to go this way. Okay. Another way of thinking of that is to put your pencil on your variable, and since the alligator is eating the n has to be bigger, so it goes to the right. Okay, example number 4 is going to be negative 10 is greater than h minus 21. Okay, to solve this one, same thing, you're going to draw your line at the inequality sign, put your pencil on your variable. Notice your variable's on the right side this time. The process is still the same. You look and see what has been done to your variable. It says minus 21, so you will add 21 to both sides. Okay, your minus 21 and add 21 cancels out, and you will be left with h. Carry down that same sign, the greater than sign. And now be careful with your integers. You have a negative 10 and a positive 21, which would end up being positive 11. Okay. So when you go to graph this, you know you need an 11, and anything bigger goes this way, 12, 13, anything smaller, 10, 9 goes this way. Since you just have the greater than sign, you do not have the line that tells you it can equal it to. You put just an open circle. And now you have to decide if it's greater than 11 or less than 11. And there's a couple ways. You can read this saying that 11 is greater than h. Or if you read it from the h, it helps us decide better. H is actually less than the 11 if we read it backwards. So it has to go this way. The other way of thinking of this is put your pencil on your variable. Remember, the alligator eats the bigger number. Since it's not eating our variable h, that means h is smaller. So our line has to go showing that any number smaller than 11 will be an answer to this equation. So 10 could be an answer, 9, 8, 7, 6, and so on. Okay, that's our examples. On your homework tonight, you're going to have problems like those 4, but you're also going to have a couple that say write and solve the problem. And those examples I want us to write on this side of our notebook. Okay, so the first example is going to be 10 less than a number is greater than 23. When we do this one, we have to look for keywords. We see that we have 10 less than. Now, we were told before that when it says less than or more than, that comes at the end of your equation because you're taking 10 away from something. So we know that we're going to subtract 10 from something, but that has to be at the end of our equation. 10 less than a number. Since we don't know a number, we're just going to give that a variable. Let's call it x. Is greater than, so we know we're going to put in our greater than symbol, 23. So if we write this, the first part is to write the inequality. So you have to use the keywords to set up the inequality. So it's going to be 10 less than, so I know that comes at the back. So I'm going to start with x, and x has to be 10 less than. I have to take 10 away from that. Is, we learned before, means equals, but it says is greater than, so you have to put the greater than symbol in, 23. And I will let you now go ahead and solve that one on your own and graph it. I'm going to give you one more example to try, and it is the sum of a number and 18 is at least 8. Okay, the hardest part of this is writing it out after you've read the words. So let's look for keywords. We have the sum. Sum means add, so we know we are adding. And what we are adding, the sum of a number, so we're going to call that x, and 18. So we're adding x and 18. And then on yesterday's video, we learned if it says is at least, that means it is at least, it has to be greater than or equal to 8. So if I were to write this out, I would say the sum. So I know I'm adding a number and 18, and it's at least, so I have to put the greater than or equal to 8. Now you're going to go ahead and solve that and graph it on a number line.